Hey guys, we're going to do 2.4 today. It's not too long, it's just about square roots. So we're going to be talking about determining square roots of rational numbers. So the first thing that you're going to see here today is that we're going to be dealing with squares, and that's why it's called square roots. And so right away, what I need you to know is that on a square, all the sides are the same. And that's what these little ticks mean. So it's super important that you remember that. And a few other things that I want to make note of right now is that whenever you find the area of something, you always use the formula area equals base times height. But for a square, there's also a special formula that you can use, you don't have to, and that's area equals s squared. Really what that means is side squared. So let's just talk about what that means for a second. S squared actually just means side squared. And on your calculator, you have a button that looks like this, most likely, x squared. And probably on that same button is your square root button if you don't have a separate one. So it's probably just hidden, like if you push second and then the x squared, you'll get the square root button. So that's where you know where to find it. So area equals side squared. Basically what that means is because a square has all four sides the same, if I had a 2 down here for this side and a 2 here for this side and we were to find the area, we would go 2 times 2. S squared is an exponent, and exponents mean a number multiplied by itself so many times, and this says that that number is multiplied 2 times. So that's why we can use this special formula if we would like to. So coming back over here to the square, this says here that area equals side squared, and it gives you that the side length, or down here, is 2.6. And so in order to find the area of this square, we would go base times height. And so here you notice that I've put 2.6 times 2.6, and I get 6.76 meters squared. Remember a few things too, that when you have this is a meters and this is a meters, and that's why we answer with meters squared. So that's super important too. We also can do side squared, which looks like this. It would be 2.6 squared equals 6.76. And you can use your calculator on that, and that's the area equals side squared formula, just so you know. So if you want to do this problem right here, you would need to write a formula that you're going to use. That's always the rule in our class. So we always go area equals, and just for my sake, I'm just going to do base times height here. Since we know that this bottom part is 3.2, we also know that the side is 3 here too. So we show our work, we write the formula, and we go 3.2 times 3.2. And if we do that on our calculator, it is 10.24. Now, since it was measured in meters, this would be measured in meters squared. So that would be your area. Area equals 10.32 meters squared. Awesome. Squares are super important when it comes to the PAT. And so I'm just going to kind of come back over here and show you this as well. In your textbook, sometimes you'll notice that it will give you the area inside of the square. So for instance, like this, area equals 36. So what that's saying is that the area of this whole square is 36. And if I wanted to know what the side lengths were, which is this side, and this side, then how would I get it? So whenever you find yourself with an area in the center of a square, all you need to do is square root that. And when you square root 36, you know that 6 times 6 is 36. So this side is 6 and this side is 6. Area equals base times height. 6 times 6 equals 36. Awesome. That's the answer right there. We know that all these sides would be 6 because they're all the same. When it comes to the PAT, everything is very spatial. And they like to ask you questions like this often. So I just wanted to demo this for you right now. If I gave you that the area over here was 4 of this square, and I wanted to know what the area of the green shaded square was. So what is the area in here? Would you be able to do it? Give yourself a second to think about that. How would I find the area of just this green square right here by only knowing that that square, this red square, the big red square, is an area of 4. So I'm going to start by writing my little ticks all over my paper here. Since these are squares up here as well, I'm going to put ticks on them as well because these sides will equal each other as well. So when we look at the diagram, we said, okay, well, I know that I can find this length up here by square rooting 4. The square root of 4 is 2. So I know that this long side is 2, this long side is 2, and this long side is 2. And so we're getting somewhere now. When we take a look at the diagram, you'll notice that these squares are kind of like half. They're cut in half of this 2 right here. So what's half of 2? Well, it's 1. So that means that every single side on this square equals 1. This one as well. So now I can actually find the area of the green square. I would go area equals base times height, and since I know that the base is 1 and the height is 1, 1 times 1, sorry, this is supposed to be 1, 1 times 1 equals 1. So the area equals 1 meters squared. Often on the PAT, they'll ask you to decode these types of questions. The last thing I want to talk about here is the word perimeter. The perimeter doesn't have anything to do with multiplying. It has to do with adding. It's really important that you know this and remember this because it's one of those things that you learn way back. So if I was to ask you the perimeter, I'm just going to draw this in a new color, of the blue area, how would I find the perimeter of that? Perimeter is adding all the sides together that you know. So we would start with 2 plus 2 plus 2 plus 1 plus 1 plus 1 and plus 1. That's the area of, the perimeter of everything around the shape, and I have drawn that in blue. So you would add this together, 2, 4, 6, 7, 8, 9, 10. So the perimeter would be like 10 meters. Perimeter doesn't get the meters squared because it's not multiplying, but you just have to remember that perimeter is adding. This is an important piece for the PAT. All right, so coming back over here into these notes, we're going to take a look at fractions and figure out if they're perfect squares. So the first thing you're going to see here is that you're given 25 over 49. This is a fraction, and they want to know, is this a perfect square? So the first thing that you're going to do is you're going to go ahead and take the product of each number. So you're going to square root the top and square root the bottom. If you look over here, you'll notice that I got these numbers. I know that 5 times 5 is 25. So this breaks down into 5 and 5. That's the top. The square root of 49 is 7. And so 7 times 7 is 49. I broke these down into perfect numbers. They don't have repeating decimals, and they are just nice and beautiful numbers. So when I actually am able to look at this, since both of these numbers have square roots, it is a perfect square. So looking at this question right here, is 225 over 369 a perfect square? If you have your calculator right now, what you want to do is you want to square root the top and square root the bottom and see what you get. I'll give you a second to do that, and we'll do it together right away. The square root of 225 is 15. It's a perfect number, and it doesn't have any crazy decimals in it. The square root of 369 is 19.209371. This number right here does not end. It continues. It just goes on and on forever and ever. That means that it's not perfect. It doesn't break down into a very nice core number. And so therefore, this is not a perfect square. All right, because this fraction does not break down nicely. So what we need to understand about fractions when we're doing square rooting is that you want to square root the top and the bottom, but you want to make sure that they break down into nice numbers that end. Something to mention here before we move on, if a number would break down into like 2.2, then it can be a perfect square, because 2.2 times 2.2 is 4.84. So the square root of 4.84 is 2.2. You'll notice how this number ends, and it doesn't go on and on and on and on like this number right here. So when a number ends, and even when the decimal just stops, then you know that this can also be a perfect square. That's just something to note. The next piece is when you get decimals, and they're asked, is it a perfect square? So the first thing that you need to do is make the decimal into a fraction. And this is where we have to go back to grade 8 and we have to remember our place values. So when we're looking over here, we'll notice that we have our place values right here. The first position after the decimal is the tenths, the second is the hundredths, the third is the thousandths, and we'll go on to 10 thousandths, 100 thousandths, and on and on and on. So when we look at this number right here, 0.4, we know that it ends in the tenths position. Therefore, you need to put the 4 over 10. So this is beautiful. Now we have a fraction, and now we can go back to doing what we learned how to do up here. We're going to see if this number is a perfect square by square rooting the top and square rooting the bottom and seeing if they break down into perfect numbers. The square root of 4 is 2, but when you do the square root of 10, you get 3.162277. That is not a perfect square. Therefore, this is not a perfect square because the 10 does not break down into a nice number. So remember that whenever you're doing decimals, you need to be able to put them back into their place values. If we look over here and I do one more example for you, if I had 0.24, so now we need to take a look at our place value to make this into a fraction, okay? This is the tenths position, and this is the hundredths. So that means that this full number is going to go over 100. So the next piece of having this 24 over 100 is that we need to square root both the top and the bottom number to see if this is a perfect square. When I square root 24, I get 4.89897948, and it goes on and on and on. When I square root 100, I get 10. Although one of them works, the other one doesn't, and so we know that this is not a perfect square. And so basically, just remember that whenever you get a decimal, you need to turn it into a fraction, square root the top and the bottom, and you're good to go. Swinging back over to the notes here, we have, I don't know what's going on. That's why. Aha, there we go. All right, cool. This is another example of a decimal, but it's a decimal that has a number in the ones position. So you have 1.44. Determine the square root of a perfect square. So this is also considered a decimal number, and we need to make sure that we put this decimal number over the correct number. So 1.44, well, we still have to look at the decimal here, and we have to look at the two placements after it. This is in the tenths, and this is in the hundredths, and that's where it stops. And so we're going to put this whole number, which is 144, over 100. So you'll notice then that we will square root the top, square root the bottom, and you'll find here that this happens to be beautifully work out, and it happens to be a perfect square. If we wanted to find out the side length of this when it's given the area equals 1.44, remember that you square root the inside, and when we do that, we get our side length being 1.2. That means that this side is 1.2, this side is 1.2, this side is 1.2, and this side is 1.2. Okay, so if you want to find the side length, just make sure you square root inside. If you want to decide whether it is a perfect square, you need to make sure that you convert this decimal and put it in the correct position. And that's it. There's one more thing that I wanted to show you, and that is something that shows up on the PAT. Do you know what the square root of 36,000,000 is? So when you look at that number, you're probably like, what? I don't know. Nobody taught me this. And I just wanted to show you how to square root huge numbers. The first thing you do is you take the number that you know here and you put the square root above it. So the square root of 36 means that that is 6. Now, just a sidetrack here, we haven't even talked about this until now, but I need you to memorize all of the times tables 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, and 12 times 12. And I need you to memorize all of these answers for the PAT. It's really important that you know your squares. So what I'm doing right now is I'm squaring numbers to get this number right here. And these numbers are going to be extremely important when solving anything to do with square roots. So, and yeah. So you need to memorize 1 to 12. So when you look here and you find 36, the square root of 36 is 6. So that's why I put 6 up here. Then I want you to count the amount of zeros that's here. So you've got 1, 2, 3, 4, 5, 6. And since the square root is kind of cutting something like a square in half, you're just going to take off half of those zeros. So we're going to take away half of them, 1, 2, 3. And then we're going to put 3 zeros up here. So the square root of this big number is 6,000. If we were to take a look at another square root, like say the square root of 81 with 4 zeros, we would first find the square root of 81, and that is 9. So we'd put a 9 there. Count the number of zeros and half it. So there's 4 zeros there. You'd put 2 zeros on the top. One more time, if we had the square root of 9 with 4, 5, 6, 7, 8 zeros, you would take the look at 9 here. We find that the square root is 3, and we'd cut the zeros in half. 1, 2, 3, 4. 1, 2, 3, 4. And that would be your answer. So this is how you square root super large numbers. Kind of important when it comes to the PAT. That's all we have for this particular thing. You can now go and do 2.4 in your textbook. As well, there is a practice square rooting assignment. So basically, it's a booklet, and you can go ahead and work in that booklet. And it's just going to help you get familiar with the square roots and just do a lot of practice in there so that you don't forget what those are. And it will also help you to remember something called fencing, which we'll show you, but just not in this video. So yeah, thanks. You can go do 2.4.